Welcome to this Math Center presentation on sets and subsets. In this presentation, we'll answer the questions, what is a set, what is a subset, and what is a proper subset. Let's start with the definition of a set. A set is a well-defined collection of objects. The objects in a set are called elements or members of the set. The phrase well-defined means that we can describe exactly what is and what is not in the set. An example of a set is the set of months in a year. M is the name of the set, and the elements of this set are the names of the months. We write out the list separated by commas. We use curly braces to show that this list is a set. This set is well defined because we can determine if an element is the name of a month or not. Another example is the set n of all natural numbers. These are the positive whole numbers starting from 1 and are sometimes known as the counting numbers. In this case, we can't write out all the numbers, so we put 3 dots at the end, called an ellipsis, to show that the list keeps going with the same pattern. Sometimes large sets are written with an ellipsis in the middle. To write all the counting numbers from 1 to 100, you could start the list with 1, put the ellipsis in the middle, and then show where the pattern ends. This funny E symbol, epsilon, is used to show that an object is an element of a set. For instance, 5 is an element of our set D, since 5 is on our list of counting numbers from 1 to 100. 200 is not an element of D, since 200 is greater than 100. We would use the element symbol with a line through it to show that 200 is not an element of D. Another way to write sets is using set builder notation. In this notation, you still use curly braces, but you would describe the members of the set instead of listing them out. You always start with the name of the set, then add an equal sign. Then use an X to indicate any element of the set. After that, you put in this pipe symbol, which is read such that. Finally, you write in the conditions on the elements and then close it with a curly brace. The example set I have here is read S is the set of elements such that the elements are natural numbers and the elements are less than 10. In this case, it is easy to write this set out as S is equal to 1, 2, 3, 4, 5, 6, 7, 8, and 9, but often the sets will be too big to write out in a list. Equal sets. 2 sets are equal if they have the same elements. Order doesn't matter when writing out sets, so you would look through the sets and see if they have the same elements in them. In this example, we have A is equal to dogs, cats, mice, birds, and B is equal to cats, mice, birds, and dogs. Since they have the same elements in them, the sets A and B are equal. 2 sets are equivalent if they have the same number of elements. In this next example, we have A is equal to dogs, cats, mice, and birds, and C is equal to 2, 4, 6, and 8. These 2 sets are obviously not equal, but they both have 4 elements, so we say that they are equivalent. Now let's move on to talk about subsets. Let's say you have 2 sets, set A and set B. Set A is a subset of B. If all elements in set A are also in set B. You can think of it like a menu. If you have a list of items and choose from that list, you are creating a subset of the list. We'll bring back our set M of months of the year as an example. The set Y is the set of all months of the year that end in Y. Notice that everything that can be found in Y can also be found in M. So Y is a subset of M. We use the funny symbol that looks like a U on its side with a line under it to indicate that Y is a subset. It may seem funny, but one important set is the set with nothing in it, otherwise known as the empty set. We write the empty set as two braces with nothing inside, or the zero symbol with a line through it. You might think it's weird to talk about a set with nothing in it, but actually it comes up all the time. For instance, we can sometimes put conditions on a set that would make the set empty. Take the set Z, which consists of all months that end with the letter Z. This ends up being the empty set. The empty set is also important because the empty set is a subset of all sets. For smaller sets, we can list out all the possible subsets. In this example, we have the set J with three names inside: Bruce, Diana, and Clark. To list all the subsets, we need to find all possible sets that can be made of the three elements in J. The first subset is a bit surprising. It is the set itself. Every set is a subset of itself. Next, we go through all possible combinations of the three elements. And don't forget to add the empty set to your list. There are 8 total subsets. In general, if a set has n elements, then it will have 2 to the n total subsets. In our case, J has 3 elements, so it has 2 to the third power, which equals 2 times 2 times 2, or 8 subsets. Let's say I gave you a menu and asked you to choose from it. If you replied, "I'll take one of everything," that wouldn't really be a proper choice. The same thing holds with subsets. A proper subset is a subset that is not equal to the original set. So all our subsets from the previous list are proper subsets, except the first one, which was Bruce, Diana, Clark, which was equal to the original set. We use a similar symbol for proper subset, but it is just a sideways U with no line underneath. We read it as the set with the element Bruce is a proper subset of J. Since the list of proper subsets is the same except for the first one, there will always be the same number of proper subsets except you take one away. Since a set of n elements has 2 to the n subsets, take one away and it will have 2 to the n minus 1 proper subsets. Thank you for watching this presentation on sets and subsets.